Hello, Anne. Um, so the way I kind of see it here, there are two things going on in some of these problems. There's the calculus end, and then uh, there's the algebra end. Because this is a calculus class, I'm going to emphasize the calculus. However, if you find that I get that part of it, I understand the calculus end of it, where I'm making my mistakes is in kind of the nitty gritty of the algebra. Let me know. Email me back, and I'll do a second video, really just hammering in on the algebra. I find myself that that's where I tend to make mistakes if I'm going to make a mistake. There's a fair amount of work that goes into the algebra. There's a lot of scratch that I did there. So what I did is I took, looking back at the problems that you got wrong, it looks like the last, I don't know, 10 or 12, 15 questions that you got wrong all seem to have to do with the same type of stuff. So I've got, when you got three things going on, you got three functions, f of x, g of x, and h of x, either in the product rule or the chain rule, or excuse me, the product rule or the quotient rule combined all together. So that's what I'm going to talk about. I'm going to try and go through as slowly as I can while still finishing my time or filling my time here. So if you look at the first problem I have, if you have the product rule where you have three different things going on, f of x, g of x, and h of x, what we're kind of doing is we're finding the derivative of each one separately while keeping the other ones the same. And one way I can kind of relate that is with heads and tails. If you're flipping a coin, so you got three coins, you need one of them to be heads. So there's three ways that could happen. You could have heads, tails, 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 heads, tails, or tails, tails, heads. Those are the only three ways that you can have one heads and two tails. And that's what we're doing with these derivatives. We're taking the derivative of the first function times the other two as they are. You got the derivative of the middle function times the other two just the way they are, and the derivative of the last function times the other two just the way they are. And I guess really you're adding these all together. So those are your three different ways that it could happen. I took one of the examples. These are the functions that I pulled out of the the Newton site. So we got f of x, g of x, and h of x here. Now, one thing you can do, we've got all this gobbledygook up here of functions, and we've taken the prime or the derivative of each one separately. You could write it out as you go. You could also take the derivative of each function separately and then fill in the blanks. So that's kind of what I've done here. I will say that if I'm doing this on my own, if I'm just doing a problem, I don't do it this way. I tend to write it out as I go. I find the derivative in my head and then write down what I need to. However, it is great practice to find the derivative of each function separately, kind of have all six written down here the way I have them right now, and then fill in, because then you've got them all listed and it's smaller pieces. So that's a great way to do it. And that's what I've got right here. I've got the derivative of the first function times the second and the third, derivative of the second function times the first and the second, and so on. Then you'd have to do the algebra. And I don't have the algebra written here for this one. I suppose I can, and I could email it to you just so you can know what the correct answer is supposed to be. But you'd have to do a whole bunch of distributing, lots and lots and lots of distributing. You distribute the -4 through, and then you distribute from there, distribute the 2 through, and it's just tons and tons and tons of distributing, and then combining like terms, which is a pain, but that's what it is. For the quotient rule, there's two things going on here. You've got a quotient, a division problem, and you have a product rule in the numerator. So there's got a whole bunch of stuff here. For the quotient rule, one thing, and you don't have to use this, but one thing my calculus teacher taught me at once, simply because he liked Disney and the Seven Dwarves, was high and ho, or high and low. So the way I remember it, and I still say this in my head when I'm doing the quotient rule, is it's ho d high minus high d ho over ho ho. So you've got the denominator times the derivative of the numerator minus numerator times the derivative of the denominator divided by denominator squared. And that just doesn't flow off the tongue as well as ho d high minus high d ho over ho ho. One thing you do have to be careful of is with subtraction, order matters. So you can't you can't flip these around. You have to do the denominator, and I've got it written over here better, or more precise anyways. The denominator times the derivative of the numerator. I'm going to see if I can zoom in here a little bit. And the numerator is a product of two functions. So I've got my derivative symbol here, minus the numerator, f of x times g of x, times the derivative of the denominator, all over the denominator squared. And that in and of itself is a lot to look at. But the product here of f of x and g of x, the derivative of that, we need to take further. So the chain or the product rule, which I just talked about up here, really we only have heads and tails this time. So we have heads, tails, tails, heads, and that's it. So we've got the derivative of the second times the first, plus derivative of the first times the second. And since that's addition, that's commutative, you could flip these around. But subtraction, you have to be really careful with. So right there, that's filling in all those different pieces. We've got the quotient rule, derivative of the numerator times the denominator, minus the numerator times the derivative of the denominator, all over the denominator squared. The product rule within that, first times the derivative of the second, second times the derivative of the first, right here. And then again, I've used the same three functions just for simplicity, as simple as I can make it anyways. And I've taken the derivative of each of them already. So I've got my 6 pieces listed here. I need to fill in the blanks. And that's what I've got right down here. Is I've got the h of x, the denominator is right there. Derivative of the second times the first, plus derivative of the first times the second, minus, and all that. And again, here's the algebra. And the algebra is tedious, it's painstaking. I get that. It's important, but it's tedious. It's a lot of distribution. So you distribute the 2 through, you distribute the -4 through, then you distribute from here to there, and then you do the same thing over here. You got 3 pieces, you're distributing over and over again. You have to distribute this polynomial piece down here where you have it squared. This, not a binomial, I don't know. And what it ends up working out to be, and you can almost see it if I get rid of my face down here. See if I can move it. It can shrink. There we go, just like Alice in Wonderland. So if you distribute it all out on the numerator for that part, and this part, and the denominator, you work out to be this answer here after combining like terms. It's not a pretty answer, but that is the derivative of that function, or those 3 functions, I guess, in that assortment. Again, I glossed over some of the algebra. If you're stuck on the calculus piece of it, hopefully this helps a little bit. I know it's not fun doing some of these long quotients. However, it's important that we're able to work through all these pieces. If you're comfortable with the calculus end of it, those are my fingers, by the way. If you're comfortable with the calculus end of it, that's great. That's really important. If you're getting stuck on all those little tiny pieces in the algebra, let me know. I can try and see if I can help you figure out where your mistakes are being made. One area to be careful of is the subtraction. It's -48 minus 44 plus 28x plus 24. So that's one place that can screw you up if you're not careful, is that subtraction is distributed through to everything inside those parentheses there. Be careful of that. Again, let me know if there's more I can do to help you. Hopefully this helped at least a little bit.